Okay, now the fourth theorem. What's the fourth theorem? This theorem will have to do with the diameter. What's the diameter? Okay, you have the center of the circle here. Okay, the diameter is a straight line that passes through from one end of the circumference to the other end of the circumference, passing through the center. So this is called the diameter. It's called the diameter. So the diameter will form an angle at the circumference, okay, from one end to the other, and this one will be 90 degrees. Okay, you can test it out. Okay, draw a diameter no matter what, how many of this type of angle you make, as long as it's from one end to the other end of the diameter with the circumference, this angle will be 90 degrees. Okay, 90 degrees. We got another one here like that. Okay, it's also, yeah, it's also 90 degrees. Okay, at the bottom can also. At the bottom cannot. As long as it makes an angle with the circumference, it's 90. Right? Next. Okay, I'm going to do the next theorem. Next theorem number 5. Next theorem number 5. This would be something to do with, now that one is diameter, right? So we have the center here. Now this one has to do with the radius. Okay, where's the radius? This is the radius. Okay, and this one, okay, is also the radius, right? This is the radius. And this is also the radius. So radius of the circle is the same, right? So you have these two lines the same. And if I draw one more line here, connecting these two radius, what do I get? Okay, this one will be an, right? If you have a triangle with two sides the same, we call it an isosceles triangle. Okay, when you have an isosceles triangle, what do you know? This angle here, let's say this is x. The other angle is also x, because same, these two angles are the same. Okay, this one is very useful. Now students don't know this, they cannot solve circle theorem problems. Okay, that's number 5. And then there is number 5. Okay, let me add a bit more for number 5. So if I have an angle, I make a 90 degree. If I make a 90 degree here, okay, then this length and this length will be the same. Okay, these two lengths will be the same. Right? Next one, number 6. Number 6 is a cyclic quadrilateral. What's a cyclic quadrilateral? A quadrilateral means a polygon with 4 sides. Okay, as long as for 1, 2, 3, 4 sides. Okay, and what is a cyclic quadrilateral? The 4 sides must okay, have vertices formed at the circumference. Every one of the vertices, okay, formed at the circumference. Okay, so this is called a cyclic quadrilateral. Okay, cyclic. So what do we know about cyclic quadrilaterals? We have this one, this angle is A, the opposite angle is B. Okay, then A plus B is equals to 180. Then you have another one. This is C, opposite one is D. Then C plus D is equals to 180. Okay, that's cyclic quadrilateral. Okay, an extension to it, okay. This is 6A. Okay, I can have a 6B. 6B here. So it's 6B. Okay, I have a cyclic quadrilateral. Remember, cyclic quadrilateral will touch circumference. Okay, all the vertices will touch the circumference. If I extend this line here, we get a straight line. Okay, and I have this angle here, X. Okay, this angle will be the same as this one opposite here, this angle X. Why? Why? Okay, who knows why? Remember here, opposite angle total is 180. So that means this angle here is 180 degrees minus X. Right? If this angle here is 180 minus X, then add together, this is a straight line. Then this angle must be X. Because 180 minus X plus X, the whole thing will be 180. Alright, so that's it for circle theorem part 1, which is angles in a circle. Okay, later we will do another part 2, where it involves the tangent.